Okay, so what have we been talking about? In the last lesson, we were talking about exponents, and it's the first topic in grade 11. And so I just want to go over quickly the laws. So we spoke about law number 1, and law number 1 is basically the additive law. If the bases are the same, we simply add the powers. So that's important. We spoke about law number 2. I call this the subtractive law. If the bases are the same, you subtract the powers. And if there are numbers next to them, the numbers, you deal with them kind of like normal. So 6 divided by 2 is 3. Then we spoke about the power law, and essentially law 3 and 4 here are the same thing. It's just if you've got a base and a power, and then a power next to the power, you just multiply them. And so how does this work in practice? If you have, let me choose a different color here. If you have this 4 outside, you multiply the 4 by the 3, the 4 by the 2, and the 4 gets applied to the minus 2. So notice below how minus 2 is to the power of 4, then the A, it's the 2 times 4 there, and is that one 3 times 4? And so you get that answer. In the last lesson, that minus 2 to the power of something, or the negative to the power of something, caught us out. So I just want to ask for a vote now. If you feel like you understand this example, give a thumbs up. If you feel like you're still unsure about how this example works, give a thumbs down in the chat. Just want to give a quick feel for the feelings in the group. I see the thumbs. Awesome. Okay, because we're going to build on that today. Okay. So the main thing that's happening here is that if you've got a power next to a power, the power simply gets multiplied by the powers inside. And so the numbers that are inside the bracket, there's a minus 2, there's an a squared, and there's a b cubed. And of those, the bases are minus 2a and b. And all that's happening is the 4 is being multiplied by all the powers inside. So 4 times 3 is the 12, 4 times 2 is the 8, and the 4 times the 1 is 4. But minus 2 is in a bracket, and so that's where we get that. Okay, so quite a few of you are also still unsure on that. So I'm going to come back to that question later in the lesson and make sure we practice it. Was there a question from somebody? Was there a question, a hand up? Okay. Then we'll down. Okay, so we're going to come back to that one. Law number 3 is still a little bit uncertain. And then example 4 is the same law. It's basically this thing that if you got, and let me really zoom in here so we don't get distracted by other stuff. If you imagine inside the bracket is a to the 4 times b. The b has a power. It's just we can't see it. It's going to be a 1. Okay. Now, what do you think is going to happen with the power that's outside the bracket? Well, the power outside is multiplied by the power inside. So 3 times 1. So that's going to give you b to the 3, which is over here. And then the 3 times the 4 is going to give you the 12. And so your final answer is a to the 12 times b to the 3. If you want to see it the long way, imagine this. So imagine a to the power of 4 times b, and it gets repeated 3 times. So that's what to the power of 3 actually means. It means repeat whatever's inside 3 times. But now you can clearly see that a to the 4 times a to the 4 times a to the 4 is just going to be that. And then b to the 1, b to the 1, b to the 1. So that's why you get your final answer of a to the 12 times b to the 3. It takes it's a longer way to do it like that. That's why the law 3 allows us to just multiply in the powers. Okay. But these are laws that are going to keep coming up today, and we're going to practice them. The other thing that's important for today is that anything to the power of 0 is 1. So you can see x to the power of 0 is 1. How would this look? Well, this thing in the bracket is something, and it's the power of naught. And so what does that end up being? It ends up being 1. What's 3 to the power of naught? It's also 1. And then together it gives you the 2. So that's going to come up. We call that's one of the definitions for the section. And then the last one is this negative power idea. If you've got a base to a negative power and you want to make it positive, generally you take it below the line, or you take it below the line, and then it becomes a positive power. So how would this look in practice? If I was on this part here, I wanted the x to be positive, the 3 stays on top, and the x to the minus 2 comes below the line, and then it becomes positive x to the power of 2. And the opposite is true as well. If I have x to the minus 2 below the line, and I bring it above the line, it becomes x to the positive 2. Can you give me a thumbs up if you understand how to change from a negative to a positive power? And give me a thumbs down if the negative to positive power is unsure for you. Again, I just want to get a feel for the group. I don't have your body language in the same way a normal classroom would have. And so it's helpful for me to see. Okay. Keep those votes coming. So for those, I see there's a couple of you who aren't sure. And so don't worry, we're going to practice this throughout the lesson today. This is just the first go at making sure we are familiar with the idea. So I'm not leaving it out. We're going to come back to it. So let's start with some multiple choice questions. And the way this works is that I'm going to give you this question. So 2 to the power of 4 times 2 to the power of 6 divided by 2 to the power of 2. And you need to tell me in the chat which of the 4 options you think are correct. And you need to use the laws of exponents and the definitions I've showed you to help. Now, everybody needs to answer. It's not about getting it right. It's more about us having sort of a class conversation on chat by voting. And it helps me as the teacher to see kind of where the group is at, because I can't see your faces. And so I'm going to give you some time now, and I don't want you to look at what other people are doing. You need to be your own person and pull the trigger, and we'll go from there. So we have 2 to the power of 12, 2 to the power of 5, 2 to the power of 8 are the choices. So law 1, or the additive law, will give me that on the top. And then law 2 says the bases are the same, so we subtract the powers and we get 2 to the 8. And so my answer is going to be 2 to the 8. And I see many of you have given C, so that is looking good to me. Okay. So that's good. You've used 2 of the laws in one question. Let's go on to another one. What does 3 to the minus 1, what does this equal? Now, this is a little bit trickier, but not too much. And let's see what you guys think the answer is for this one. How do we deal with a negative power? How does that work? So in the earlier lesson, when we wanted a negative power to become positive, we had to take it from being the numerator to becoming the denominator. So we take it below the line and we get 1 over 3 to the 1, which is 1 over 3. And so the answer is C. Yeah, C, not so bad.
Well done,
Okay.
guys.
Yep, smashing it. In fact, I feel like we're leaving the warm-up stage of the lesson. This is awesome. Third question. What does 4 to the power of minus 2 equal? I want to see if I can get the question so there's a bit more variation in the chat. Then I know in that Goldilocks zone where there's debate in class. A couple of different options coming through. I like what I'm seeing. There's a nice bit of debate. Normally in this section, we like to have positive powers. So one of the things I often tell students is even if there's not a denominator, you can always think of there being something over 1. And so if you imagine me changing this and I bring the 4 to the minus 2 below the line, it becomes 1 over 4 to the power of 2. Now, I don't see that anywhere here, but maybe that can help in answering the question. Because we know 4 squared is 1 over, well, 4 squared is 16. And so the correct answer, is there a 1 over 16? Yes, there is. I just want to ask, are there does any student have a question or a comment about that? Because now is a good time. Otherwise, I'm going to move on. But I just want to ask in the room, is there anything that needs to be clarified, or is the rule making a bit more sense there? Okay. I don't see anything in the chat, and I don't see any hands. So let's get the party rolling. Next question. What is 7 to the power of 5 times 7 to the power of minus 2? So ask yourself, what laws are applicable and how do I apply them? Who would like to come online and explain to me how they got the answer to this? I'd love to hear someone's voice. Who would like to tell me how they got the answer to this? Just pop your hand up and you can just tell us what you were thinking. I'd love to hear your thinking on this one.
Anybody? Promise we're nice.
Who's feeling? Just pop your hand up. What about you, DeCarlo or Philly? Or Nati?
I think our people are feeling a little shy today.
Shy. I just want to know what you were thinking. You don't have to get the answer right. I just want to know what you were thinking when you did the answer.
Craig.
Let's go to Craig. Yeah. Hey, Craig. Can you hear me?
Yes.
How's it going?
That I was thinking, I'm okay, and you, sir?
Very good. Oh, sorry, I just pulled the trigger on my, don't know what happened there. I'll be with you in a second, Craig. I got a bit, there we go. What were you saying?
The law that I was thinking was distributive law, which is taking the 7, and since the powers are different, but the bases are the same, you just say 5 minus 2, which gives you your answer.
Yeah, the main thing, Craig. Yeah.
Which would be 7 over 3, or 7 negative 3.
7 to the power of 3.
Yes.
Because isn't 5 minus 2 is 3. The main thing that I liked, Craig, was you noticed the bases were the same, which basically meant you had to add the powers. So 5, I suppose I could have written it like this, 5 plus minus 2. But plus minus 2 is the same as writing 7 to the power of 5 minus 2. And so the correct answer should be 7 to the 3. Thanks, Craig. All right. And so the correct answer for this should be C. Okay, we'll skip that one for now. Let's do this one. So you've got this 2 to the power of a third times 2 to the power of 2/3. What do we think the answer to that is going to be?
Go for it,
What
guys.
law
You're
do-
doing so well.
The question is, what law is involved? Because what I notice now is there's some fractions. So it turns out powers can be fractions. So that's new. But what is the main idea we're looking for here? And I think I'm going to take Craig's advice. And I noticed that the bases are the same. And I feel like that is going to mean that I write down a 2. Now it's just a question of what the power is. And law 1 says just add the powers. So 1/3 plus 2/3, but now I know my fractions. If they both have denominators of 3, it's just going to be 2 to the power of 3/3, but that means it's 2 to the power of 1, which means it's 2. So A is going to be the correct answer. And if I look at the chat, it's a lot of A's, a lot of A's. So I'm gonna just a quick pace check. If you feel like the pace of the class is good so far for you, give us a thumbs up. If you feel like we're going a little fast, give a thumbs down. Just want a quick little check so that I can, again, I can't see your faces, and so it's nice for me to just get a feel for. Okay. Cool.
We are ready
Okay.
for more.
Okay. So what I'm getting the feeling is that I need to, the fitness class needs to go up a notch for the people to truly. Okay. Next question. I'm going to try and rub this out. There we go. What is the answer to the next one? 2 to the power of 3 divided by 2 to the power of 4.
Ooh, turning up the heat a bit.
Yeah, the numbers are on top and they're on the bottom.
You can do this, guys.
Okay, the people have spoken. This is not even challenging anymore.
They're like, nope, Mr. S, you're not going to catch me out.
The answer is B, 2 to the power of -1. Okay, maybe I'll catch something on this one. So let's see if we can get this one. New question. What is the answer to 2 to the power of -3 over 2 to the power of -4? And I'm going to try and rub out my funny box here while you work on that. This is a little bit trickier because there's negative powers. And so maybe that will, I don't know why that thing is not going away, but maybe I've made it angry again. So I see some debate in the chat. I see A's and D's. Lebo, are you seeing that? Like
Yes,
that's what
I'm seeing that, Mr. S.
It seems like the debate between A and D. Now, would somebody like to come on and explain their thinking for this one? I'd love to hear someone's thinking around. I know the bases are the same, right? So there's no debate about that. I can clearly see the base is going to be 2. What I want to know is how I handle these bits here. Okay, so let's go to Sino. Sino, can you help us with the thinking? Can you hear me, Sino?
Yes, sir. Hello.
Hey.
Yes, so they are the same bases, and because we're dividing, we subtract the powers. So it'll be -3 in brackets,
Yeah.
minus -4 also in brackets, and that gives you 1. So it's 2.
Okay. So what is happening over here that's really important that you seem to have realized?
A negative and a negative gives you a positive.
Exactly. And so that's why you get the 2 to the 1, and that's why you get your A as the answer.
Yes.
Awesome.
Nice one,
Awesome.
Sino.
Very nicely done. Okay, let's do this one. I want to know what is the answer to 2 to the power of -3 to the power of -5. Give me an answer to that.
Keep those answers coming.
Okay, so you guys know that you multiply these two powers, and -3 times -5 is just going to be +15, which is C. Awesome. This is like we're just rolling through this. So I think what we need to do is we need some proper like written questions here just before we take our break. So what I want you to do is I want you to try and do for me these. Let's do 1, 2, 3, 4. We're going to do these 4 questions now, and you're going to do them by yourself. Then once you've got the answer, you can put the answer in the chat, and I'm going to give you 3 or 4 minutes to do that. And then we're going to have I'll give you the answers, and then we'll have a break.
Go for it, guys.
And then if anybody wants to ask a question, just pop your hand up and we can have a chat while students are working on this. So pop your answers in the chat. And again, it's not about really being right in the chat. It's more about giving us a window to what the class is thinking. Also, it allows us to be visual with your thinking. It's showing me a window into your thinking. So please do participate. Also, we know from research that just being active means that when I reveal the answer, you'll remember it better if you've been active as opposed to passive. So I'm seeing in the chat, a lot of people are noticing that the bases are the same. And so for the answer for the first one is just y to the power of 2n plus 5. Oh, what happened there? For the second one, I like to write it like this sometimes. It helps me understand what's going on there. And in fact, for those who are feeling like you've got this, give number 5 a go as well. You can do number 5 as well. So the fifth one is just begging to be answered.
Looking good, guys.
Sakila, I like what I'm seeing. Sichaba, Boitemelo, I like what I'm seeing. So this one, let me actually do this. So that's that one. Now, 4 and 5 are a little bit trickier. So we have to be a little bit more careful, but let's do them. There's actually different ways you could do this. my tip to you is to say the 3 needs to be applied to that, to that, to that, and to that. And what are the powers of the numbers? There's just going to be ones there. So remember, if there's nothing there, it's just a power of 1. How can you use that to help you? Lie 3. What's 3 to the power of 3? It's 27, actually. Are there, I'm interested to know, are there questions about question 4? Otherwise, if there are no questions, then you can try to do question 5 as well. Oops. My warning on question 5 is watch out for the -3. And to also ask you, what does this 2 do? So remember from last time, -3 is in a bracket to the power of 1, and you've got y to the power of 3. And each of these gets raised to the power of 2. So -3 to the power of 2 is going to be 9. And y to the 3 to the power of 2 is going to be y to the 6. Because the 2's are being multiplied. Yeah. Okay, so the answer is 9 times y to the power of 6, like that. And then the fourth one's answer was like that.
Good work, everyone.
Okay, so we're definitely getting harder now. And so we have worked a solid half an hour now. And so what I want is I want for everyone to just, so isn't the negative, okay. Sia's asking a very good question. Shouldn't the 9 be negative? Sia, because the -3 is squared, what that is actually doing is it's saying repeat whatever's there inside the bracket twice. And so because you have 2 -3's, what is -3 times -3? It's +9. And what's y to the 3 times y to the 3? It's y to the 6. So it's actually not a negative. Okay, cool. What we need now is a bit of a break. And so I want everyone to turn their cameras on. I'm going to, what I'm going to do, I'm going to turn my, wait, stop share. There we go. And I would love it if you would join me in standing up and just stretching it out for a second. Lebo, if you can help us to. Oh, we've done some hard work. And
Please turn on your cameras, guys. We love
We
to
want to
see your
see faces.
faces. Join
Yeah.
us in the stretch. Give your mind a break.
Okay, let's start with some loosening of our shoulders, because we know when we sit and we look into the screen, the first thing is you go forward, forward, forward. So just loosen up those shoulders. There you go.
As Pogasi says, their camera isn't working. It's okay.
Okay. And then maybe just wind your neck a little bit just so that it can kind of one side. Oh, some good clicks. And then let's do this.
Seems like our people are struggling with their cameras today in the chat.
Something like this. And you can just feel how your body's like, thank you for standing up. Like you were not designed for sitting forever. Like that is unnatural. And the moment you just, let's shake it out. And so what this allows your brain to do is it allows your brain to like feel like, oh, I can relax, take some time off here, and it's packing away all that learning that you've just done.
Yes.
Storing it like long-term memory.
Shout
Okay.
out to all of you guys.
Awesome. Ayanda, Nompolelo, Nati, Nsako, Annie, you are looking awesome. So let us do a little brain break question just to follow up. It was Christmas recently, and so I want to know what is a Christmas tree plus a barbell plus a present box? And I want to see in the chat what you guys think that is, using the common sense logic. All right. Okay, Kumo is giving us some good guidance there. Kumo, I think I'm with you on that one. So there's no doubt that the Christmas tree has to be 5, because there's no other way for something that's the same to give 10. I'll put this above here just so you can see. And Sino has said that's 7, which I agree with. So who has the final answer for me? Or some of you already got your final answers. Oh, I see 25 coming in. I suspect that's the 13. Yes, so 13 plus 7 gives you 20. And so I've satisfied all of those. And then it's plus, plus, plus. And so the correct answer is 25. Well done.
Awesome stuff, guys.
So these are actually simultaneous equations, and they're not so bad. Cool. All right. So just give yourself one more shake, and then you've done really well. We did a nice stretch, a nice little brain break, and let's go back to the topic at hand. So let me take you to, should we do that question? No, let's just do these 3. Okay. So first of all, I want everyone to try and do question A. I want you to do question A, and then I want you to put your answer in the chat.
Mr. Is,
Yes.
while they do that, is it possible to please explain number 5 for Annie again?
Let me go and see if I can grab number 5. I'll go and, yes, okay. Let me go and grab number 5. See if I can get it. And while everyone else is working on that, I'll do my best. I'm not sure if I can do that. I'll try later in the lesson. It's just a little bit too much juggling right now.
Thanks, Mr. Is.
Yeah. Is my camera looking at me again?
Yes, yes, it is.
Cool. Thanks. So what's the answer for the first one? And then for those students who are feeling comfortable, we also will do B as well. So we will also do B, but mainly focusing on A now. Just if you are free, we can. Okay, so for A, you should get 12a to the 7 times b to the 6. And Annie and Eunice, I see you've got that perfectly right. Let's see how we can go on B. And I also want you to try and do C as well. And that's it. Then we're going to move on to a different type of question.
Keep going, guys. Almost there.
Yeah. I always like to rewrite my divisions. You don't have to do this, but I often find it helps to visually see a division as the numerator divided by the denominator. It just somehow makes it clearer, because I can see that like the 12 is being divided by -4, and I can ask myself, what is 12 divided by -4? I can look at this. What is this divided by this? What's this divided by this? That should help you. Yeah, so the thing to watch out for is the number 12 is a positive. The number -4 is a negative. Positive divided by a negative is a negative. Okay, so that's the answer for A and B. It's just C we have to do still. Who would like to explain C to us? There's something a little sneaky about C, and I want to see, excuse the pun, if anybody is willing to help me out
A
here.
hand from Sino and Sia.
Okay, let's go to Sia.
Okay, Sia. Can you unmute Sia?
Afternoon, so
Hey, how's it going?
so I'm not sure if I'm completely right, but I did it my own way, where I just put every number in their own brackets and put it to the power of 3.
Okay.
And then my answer, the answer I got was -27, a to the power of 9, e to the power of 6.
Okay, so I totally agree. Basically, what you've said is you put everything that was there in a bracket. So let's just do that. And then you applied the 3 to each one. And you got
Yes,
-27, a to the 9, b to the 6, which is perfect.
Yes, sir.
Yeah, absolutely. The thing I was worried about was just people recognizing that -3 to the power of 3 was -27. So that was, but thank you. You spotted that straight away.
Thanks, Sia.
Awesome. Okay, everyone. I think you've got this one waxed. So we're just going to look at one more type of question for today, and then we're going to call it a day for today. All right. Now, we're going to start with this today, and we'll continue with it in the next lesson. The key word for this question is to simplify. And I would like some suggestions from the class, because maybe you've seen a question like this before. Maybe someone can give us a hint as to how would we begin simplifying a question like this, because the problem I see is that the bases are not the same. And if the bases are not the same, I can't use my laws. So let's go to Asa. So what do you think? What techniques have you heard about if you had to simplify something like this?
So I think you have to first find the highest common factor, or first put the bases into their prime factors and then find the highest common factor.
Okay, you are smashing it. The problem is that there is no same base, but if you break the bases down, I think it's possible to write it so that you can have the same base. And so what I want everyone to do now is I want you to try and break those bases down and then see if you can solve this question. I'll give you a hint. The very first one is a prime number, so it can't be broken down any further. But 4 can actually be written as 2 squared. And that's good news because now the base is 2. But the one problem is you have to deal with this part here. Now, Oratile is asked, can we multiply the 2 and the 4? What we want to do, Oratile, is we want to make sure that the bases are the same. And so at the moment, what I'm doing is I'm breaking down the 4 into 2 squared, and the 8 gets broken down into 2 to the power of 3. Now, what I'm going to recommend is you put a bracket around the power that's outside here. Just give me a thumbs up if everybody's followed the stuff in red. Thumbs up if everybody's followed the stuff in red. That's step 1, to break down your bases so that they all are the same base. Okay, great. But now here's the next problem. We have to multiply this 2 by this n plus 1, and we have to multiply, okay, there's a 1 here, and that has to get multiplied by, the n plus 2 has to be multiplied by the 1. And then here, this has to be multiplied by this. But now what students forget is when we are multiplying, you don't just, the first one is easy. So you write down the base, and 1 times anything is still n plus 2. But for this next one, when we multiply, the 2 gets multiplied by the n, and 2 gets multiplied by the 1. And so we get 2n plus 2. And on the bottom, when I go 3 times n, we get 3n, but we don't get 3n minus 1. We get 3n minus 3. So the thing that I've seen in my years of teaching is that students forget that the 2 inside needs to be multiplied by both. Give me a thumbs up if you understand how I got this bit and this bit, because that's really, really important. Okay, now I want you guys to finish this question off for me, and I want you to try and get me the final answer to the question and then pop it in the chat. Awesome. Awesome, awesome, awesome. What is the final answer going to be here? And what are the laws we're going to have to use? So on the top, what do we have now? We have 2 to the 3n plus 4 over 2. What do we still have to do now? So we leave this like this, and we subtract the whole thing on the bottom. And there's different ways of doing this. What we should get is 3n plus 4 minus 3n plus 3. And so we get, this cancels out with this, and 4 plus 3 is going to be 2 to the 7. Now, that might catch some of you by surprise. So let's just zoom out so we can see the whole journey here. What is catching you guys out, some of you, is that when you take this power on the top and you subtract this thing over here, you have to put it almost like in a bracket. And so when you write this, you go 2, and then you have that whole thing minus that whole thing. And because the negative is in front, it's not just minus 3n, it's minus 3n, and it's also minus 3, which just gives you the plus 3 down here. And that, I suspect, may have caught quite a few of you out there. Are there any questions or comments about that? We're going to practice that again in the next lesson, but I just want to get a feel for the room as to how basically that 2 to the 7 part went down. Are there any questions or comments about that? Okay, so in the next lesson, we'll continue with these. This is a typical type of grade 11 test question. And so we will practice this more next week. But the focus this week was just on getting your knowledge of the exponent laws a bit better, and then building up to types of test type questions. And you can see how we use the laws throughout this. We broke down the bases. In fact, this is how, there's a little thing here that shows you how you solve questions like this. And we're going to use this as our guideline going forward into the next lesson. So you rewrite all composite numbers as a product of their prime factor. So that's what we did with the 2's. We use the exponential laws to raise all the powers. And then we use the rule for division to move all the bases into the numerator. Okay. I suppose what we did there was we subtracted things. What we could have done is, if we moved the stuff from the bottom to the top, we could have also changed it to negative 3n plus 3, which would have been basically taking this thing at the bottom. And if you take it from the bottom and you bring it to the top, the power would go to negative 3n plus 3. And so that's another technique which I will talk about in the next lesson. That would also give you the same results. Okay.